welcome you to the series on frequently asked questions, FAQs on structural equation modeling, part 5. We have already discussed some of the critical and important questions on structural equation modeling as a part of our first 4 videos. And today we will discuss part 5 on FAQs on structural equation modeling. I am Professor Jitesh Thakkar. I am an author of the book Structural Equation Modeling, Application for Research and Practice with MOs and R. This book demonstrates the application of structural equation modeling with a step-by-step procedure for various real-life application problems. I am Dean Academics and Professor Logistics and Supply Chain Management at Gati Shakti Vishwavidyalaya, Central University, Vadodara. I was a faculty at IIT Kharagpur and has a professional experience of more than 25 years. I am a faculty expert at leading institutes, IITs, IIMs, NITs, and others. And I am listed in the world ranking of top 2% scientists by Stanford University. Let us continue in our discussion and evolve greater and better understanding on structural equation modeling. Let us see the first question as a part of this series, part 5 on SEM. Question is, I am investigating a problem in social science. What would be considered as an adequate sample size for SEM analysis? This is always a very critical question, and researchers, analysts would like to understand what should be my sample size so that the reliability of my results can be ensured. As a rule of thumb, SEM examines the complex structures explaining a particular theory and requires sample size of around 200 as a rule of thumb to examine basic models. However, if you are dealing with a higher model complexity, including more number of observed and latent variables, then you need to consider more than 250 samples for achieving better statistical power. Two popular assumptions are that you need more than 200 observations or at least 50, more than 8 times the number of variables in the model. A larger sample size is always desired for better statistical power in SEM. So this, I think, clears the idea that around 200 observations and scaling up as your model gets more complex is the rule of thumb. Question 2 is, what are common software packages used for SEM and which one is recommended for the beginners in India? There are various software packages available like MOS, analysis of moment structures. It's quite user-friendly graphical interface, part of IBM SPSS, and this is excellent for beginners, widely used in social sciences. M+ is another, very powerful and flexible, capable of handling complex models, multi-level SEM, categorical data, and more command line based. The third software package that you can use for structural equation modeling analysis is R. Open source, it's highly flexible, free, absolutely available, requires coding knowledge, but has excellent community support. Smart PLS is another option, specializes in partial least square SEM, PLS SEM, and this is more suitable for prediction-oriented research and situations with non-normal data or very small sample size. So it is also visually driven. So a couple of recommendations about the package for beginners in India is that MOS is often recommended for beginners due to its intuitive graphical interface. This allows users to draw models and run analysis without extensive coding. Smart PLS is also a good option if the research focuses on prediction and the data might not meet all parametric assumptions. And for those comfortable with coding, R is an excellent free open source software available. So in summary, MOS is popular for the beginner because of its graphical interface, removes a lot of coding hurdle. Smart PLS or R package step in when you need prediction focus or full flexibility really that can help you to analyze the SCM model. Question 3. What are the key precautions in the use of SCM techniques? There are 6 precautions in the use of SCM techniques. Number 1, SCM is used as a confirmatory technique and a researcher must specify a full model a priori and test that model based on the sample and variable included in your measurements. This demands knowing the number of parameters one need to estimate, including the associated covariances, path coefficients, and variances. It is also important to deduce relationship from prior theory or experience between the variables in SCM model. Number 2, SCM is used to model complex relationships between multivariate data, and hence sample size is an important issue. And as I mentioned, that the recommended sample size is 200 or at least 50 more than 8 times the number of variables in the model. So a larger sample size is always preferred. Like other multivariate statistical methodologies, most of the estimation techniques used in SCM require multivariate normality. Your data need to be examined for univariate and multivariate outliers. Transformations on the variable can be made. However, there are some estimation models that do not require normality. Number 4, SCM techniques only look at first order linear relationships between variables. Linear relationships can be explored by creating bivariate scattered plots. It's a very famous handy tool for all your variables. And if a relationship between two variables seems to be quadratic, then power transformation can be applied. Number 5, there is a key concern for multi-collinearity among the independent variables. For manifest variables, most programs will inspect the determinant of a section of your covariance matrix or the whole covariance matrix. A very small determinant may be indicative of extreme multicollinearity, which induces significant error in your analysis. It is expected that in SCM analysis, the residual of the covariances need to be small and centered about zero. Some goodness of fit test like Lagrange multiplier test remain robust against highly deviated residuals or non-normal residuals. So these 6 precautions typically reminds us that SCM demands careful planning from defining the full model in advance to checking the normality and multicollinearity, paying attention to the outliers, residuals, and proper estimation methods will keep our finding robust. So we have broadly covered as a part of frequently asked questions on structural equation modeling part 5, sample size, software choice, key precautions to conduct our SCM analysis correctly, effectively, and deliver the impactful recommendations for the situation under investigation. Thank you very much for your interest in understanding structural equation modeling, and we will keep discussing various issues in this field through my YouTube channel.